Well, hello everyone. Welcome to Panna Cotta Fuga and Narentia's math class. Today I'm going to talk about Taylor polynomial. Many people might think that Taylor polynomial is hard to understand. In this video, I'd like to talk about my own understanding about it. Hope it will help you. So, what is Taylor polynomial? Of course, it is a polynomial. But why does it look so horrible? And why is there an n factorial? What's the relationship between Taylor polynomial and the general form of polynomial? Well, this is the general form of polynomial. And the a's are constants. So here, I'm going to give you an example to explain their relationship. For example, first, let's approximate a function fx equals sine x at x equals 0. So how can we approximate it? Well, I take the first 5 terms of Taylor polynomial. Of course, you can take as many terms you like to approximate a function. So I write it at here. And sine x at here. In this polynomial, each term corresponds to a derivative of sine x. So a0 corresponds to the zeroth order of derivative of sine x, and a1x corresponds to the first derivative of sine x, and so on. So let's first calculate the zeroth derivative of sine x. Of course, it is just sine x. And x equals 0, so it is 0. So a0 is 0. Then what about a1? We need to take the first derivative of sine x, and it equals cosine x. So it's cosine 0 at here. So it is 1. And we also need to take the first derivative of p and x, which is the first derivative of this one. So we cancel a0, and for a1x, we left a1. So a1 equals 1. And then it is the second derivative. So it equals minus sine 0. And it is 0 again. At this time, we need to take the second derivative of p and x. So we cancel a0, we cancel a1x, and at here we left 2a2. Because when we take the first derivative, this term equals 2a2x. And then when we take another derivative, x is gone, so we left 2a2. And this equals 0. So a2 is 0, or we can write it in the form like this. Then how about the third derivative? So the third derivative of sine x is minus cosine x, and it is 0 here. So the value is -1. So this corresponds to a3x cubed. So at here, we take the third derivative of p and x, and we left the factorial of 3 times a3, and it equals -1. So at here, a3 equals the third order derivative of sine x over the factorial of 3. And then it is the fourth derivative of sine x. So it is sine x. It's 0. So at this time, it is 4 factorial a4 equals 0. So we can get a4 is this one. So why does it make sense? First, let's have a look at the graph of sine x. If we want to approximate sine x at x equals 0, of course we need to make this polynomial equals 0 at x equals 0. So a0 is 0. And then we need to make p and x to fix the slope, to fit the slope of sine x in order to better approximate it. So in this way, we cannot make p and x like this one or this one, because of course their slope doesn't fit the slope of sine x at x equals 0. So at here we need to take the first derivative of sine x in order to make the slope of p and x equals to the slope of sine x at x equals 0. And for the second derivative, it fixes the curvature of sine x at x equals 0. So when we do the derivative of sine x again and again, we just want to make p and x to fit sine x better and better. And in this process, we can see why there is an nth factorial, because we take the derivative of p and x again and again. So this power just become the factorial, like this one, these two, and this one. So at last, how can we express the approximation of sine x at x equals 0 in Taylor polynomial? So it is at a0, it is 0 plus x and plus 0 plus plus 3 factorial and plus 0 and so on. But what about when we're doing the approximation at an x value that is different from 0? Like x, for example, like x equals pi over 2. Well, It is almost the same process as we do in the approximation at x equals 0. We take the derivative of sine x at pi over 2 again and again. So we can get the nth of derivative of sine x at pi over 2. And we can also get the nth factorial of it. And at here, we can just treat it like the situation when x equals 0. So at this time, Pnx is equals to a0 plus a1 x minus a plus a2 x minus a squared, and so on. So at here, we can rewrite the Taylor polynomial in this form. So this is the approximation of a function at x equals a. So this is my own understanding about Taylor polynomial. Hope you like it.